All right, mic works? Mic does work. All right, hello everyone. So yeah, this is me. I work at DoorDash on infrastructure and trying to get us to get into some better architectural patterns, which means for the last 2 years or so, I've been involved in this very complicated migration. And before that, I worked at Uber on a bunch of similar things. And so I've been around this space for a while and want to share a little bit of what I've learned, and hopefully maybe it can ease some of your pain if you encounter this kind of thing in your job. So migrations. Here is the question to get us started. Nobody really wants to do these things. Right? When you mention it, people go, oh boy, migrations, like they're associated with bad, like the not fun part of working in computers, right? Because they're really hard, and they're hard for any number of reasons, but which I'm going to get into. But I'm always struck by whenever you ask software engineers, like what kind of problems do you want to work on? They're like, ooh, what are your challenging technical problems? Like what's really hard at DoorDash? And I'm like, well, this migration has been taking us 2 years. It's super hard. And they're like, oh boy. So apparently software engineers don't want to work on hard problems. Like, I don't know. I think they want to work on greenfield problems is what they want to do because they're actually easier. So fun paradox. Anyway, you will all, by coming here, have made an important decision, and it should be recognized. If you care about migrations, clearly you're enlightened, you're wise, you're above average attractiveness, and you should get a raise. If your boss is here, let them know. Migrations, super hard. All right, very good. So now that we're all friends, let's establish, kind of what specifically we're going to talk about here. When I say migration, what I mean is if you have a system that's already working that you depend on and you need to make some major change to it, like it could be decomposing your monolith, or it could be like a database migration, like you have one kind of database and like you wish you had another database, okay? Or a different kind of database that does, sort of the same thing but in a, better way somehow. And this is particularly the example I'm going to use is kind of focused on going from small to medium, and both in terms of like business size and sophistication. But I think the recommendations are applicable to sort of any level of company size or technical sophistication. Okay. So let's get into this. Here, like why really is this so hard? Well, one big obvious reason is usually if you're doing a migration, it's because you got something that was written a while ago, okay? Maybe a year, maybe less if you're lucky. And if you're lucky, the reason you're lucky is because then the people are still around who actually understand it. If you're unlucky, then maybe they have moved on and maybe nobody really is exactly sure how this thing works, or the institutional knowledge might have sort of atrophied a bit. The other thing is when you're writing software, typically you're not thinking, what happens when we want to replace this? Like when you're building some system, you typically are focused on your product features or whatever you think good software looks like, and you're making your various trade-offs, and you rarely do you think, what happens when this thing needs to be replaced? You're like, well, that's going to be someone else's problem, right? Like, it usually is. But sort of the next level of detail is like when you're actually making this stuff, when you're actually making software, it's really hard to know. You've got some goals you're trying to achieve, some business need you're trying to meet by writing your software. It's hard to know the ways in which you're going to want to change this thing in the future. It's hard to actually even know why you're writing it if you're doing it right, or if you're inadvertently, creating more code that you hate, or also known as technical debt. It's hard, right? Software is hard, right? That's why they need like big rooms full of smart people like us, right? But so this is the problem. Like it's hard to know when you're writing software how to make it flexible in the right way that will make a migration easier. And increasingly, a lot of us work on systems that you cannot turn off. Like they just have to be on all the time. Like there's no maintenance window, there's no just reboot it, like to install the new version. If you ship a video game binary, you can restart it, a mobile phone app, right? You can restart the app when you install a new version. But most service backends these days, you kind of can't take them down. And that is a relatively new phenomenon. Historically in software engineering, we have not had very many systems that are like this. But now we've got a lot of them. So that's what makes it hard. And so if you've got one of these systems that you can't ever turn off, there's some rules that you basically need to follow, which is everything you do must be forward and backward compatible, because you can't turn it off. And importantly, you're probably going to make a mistake in the process. So you're going to need to be able to roll it back. The default answer, if anything ever goes wrong when you're working on one of these systems, is just roll it back. And note that it doesn't mean take it down. It means, because your changes are forward and backward compatible, it means rolling it back online. And the system still stays up, and hopefully you didn't, corrupt any data or do anything really bad. So I'm going to take you through how, this big migration that DoorDash is just wrapping up now. As an example, but I think you can sort of see how these type of techniques map to all sorts of different migrations you might undertake. So first, quick bit of history. This is the first commit to DoorDash. This is Andy Fang in his Stanford, I think it was in his dorm room, I don't know, but it's Andy Fang at Stanford, nearly 10 years ago, laying down that first commit. So there he is, initial Django project, and Andy still works at DoorDash. If you were to say, hey, Andy, we're having this problem with a Django thing, he'd be like, I don't know, I have no idea. I wrote that thing 10 years ago. I really have no idea what it is now anymore. And furthermore, if you'd asked him, when he was writing this thing 10 years ago, do you think this thing will still be around in 10 years? He would almost certainly say, no way. Why? Why would it be around in 10 years? We're just doing our Silicon Valley minimum viable product, right? It's minimally viable. I'm not building some enduring architecture for the next decade. And yet, I ran this on my laptop just the other day because this is still the active repo for this thing that is still in production. So, just barely in production. It's almost gone. Okay, so this is a super simplified example of the kind of major components at DoorDash. So eventually it was more than just the Django as with the browser clients, and eventually we hired more engineers and we wrote some native clients in iOS and Android, and we got a security team and don't expose any of this stuff directly to the internet. All that stuff. Okay, cool. So then there's Django, right? So this is our Python monolith, and Django, of course, talks to Postgres. Postgres being the only correct choice. If you ask anyone on Hacker News or Twitter, they will definitely tell you this. Do not even think about using a different database to start your initial project. Just use Postgres and save yourself a lot of internet grief. And that is certainly what Andy did. He did not want to get bombarded by sort of care-mad engineers telling him that the various virtues of databases. He's just like, Postgres, no one's gonna hassle me about making this decision. Okay, cool. So we got this thing, and it's working pretty well. It has a lot of benefits. The working in this single code base, right? So it's like a single Docker container gets built, has all giant pile of Python in it, and when you release it, you can do atomic changes. So you don't necessarily need to do migrations inside of this monolithic Python code base. That's the cool part, right? So you can change code and you can change a bunch of APIs internally around, and you can roll them out, and this works pretty well. And at small team size, this was working pretty well. People were all kind of working in the same code base, and the company's growing, and this is going pretty well. But then eventually, the things started to go not so well, which is eventually the test suite started to get really slow. It started to get really flaky, and developers started, with enough more developers, they're changing things faster than the kind of release train process that we had set up could accommodate. And so, the chances of shipping a bug to production are always, non-zero. But with that many more engineers writing that much more software, some tests or some bugs evade the test suite, they get shipped to production, and now they got to get rolled back. But now you've got way more of your colleagues' code on the same release train that all gets rolled back. People are increasingly unhappy. So we got to do something about this because it's sort of collapsing under its own weight. So the first thing that we did is people reasonably observed that while it says iOS client and Android client, there's actually 2 iOS clients and 2 Android clients, because there's the consumer app, which is the one you've probably seen if you use DoorDash, but then there's the Dasher app or the Driver app. They're separate apps. So what they did was they made 2 deployments of Django. And internally at DoorDash, we abbreviate Dasher as DX and consumer as CX. So that's why that says that. Anyway, so now we've got 2 independent deployments. They handle, it's the same code. It's the exact same thing, but they can be released independently of each other and rolled back independently of each other. And we had the network layer. We just make sure that we only send the APIs, the HTTP requests that correspond to each one of those, each one of those Django instances to the correct one. And we're still using the same sort of shared Postgres server here. And so we did actually a few more splits like this, but it only delayed the inevitable, because remember, each one of those blue boxes is actually the same code. It's just that they're deployed independently and they have different sort of externally facing APIs get routed to them, but it's the same stuff, right? So, okay, so it's getting worse, and I want to point out that a neat thing that Django and a lot of sort of monolith architectures have is they have an ORM, and an ORM is an interesting trade-off. It is especially interesting, and when you look at that diagram, maybe you can see why. And that's foreshadowing. So now we must decide. We must do something, right? Where this thing is collapsing, something has got to give. So we got a couple of choices. One, rewrite the whole thing. Definitely that's going to fix the problem. But when? Like no one knows, right? And also, what is the problem? I guess the problem is the way we designed the internal Python interfaces wasn't right, So we need just a major refactor to make it so all this code that we've written is actually organized in a sort of usable way for as many engineers as we have. So one way you could do that is you could rewrite it, and obviously we're not going to do that. So we're going to break off some small pieces, right? Obviously we're going to have to break off some small pieces. There's no way we're rewriting this thing. We can't take it down. Cool, so break off some small pieces it is. So for example, what if we had those green boxes there? What if we had a order service and a cart service and a order database and a cart database? Sounds pretty good. So how do we get that? First of all, I'm going to give you a few options here of ways in which we could get to this point. And I just want to get it out of the way right now. This all sounds bad. It's ugly. It is not elegant at all. It might require kind of some trade-offs that might make you sort of nervous, or just sort of feel like, this is gross. I don't know. They all sound bad, and it's because they are all bad. These are not easy things to do. There are sort of there's no good options, but there probably are some least bad options. But remember, you're the one that had to go and have a successful business, so it's kind of your fault. So just keep that in mind. So recall that if we are making changes to an always-on system, everything has to be forward and backward compatible, right? And if anything goes wrong, we're gonna have to roll it back. Cool. So with that in mind, I'm gonna start explaining some of the different ways in which we could do that. And this is a generic way of describing this technique. Depending on like which blog posts you read or whatever, they might call this something else. But I like to call it dual write because I think it emphasizes the gross part. So in this case, we got a client, we got an old service, and we got that their client is currently using, and we got a new service, and we wish the clients were using that, right? So the first thing that we do is we get some kind of a backfill or a sync, some kind of thing that runs not synchronously, but synchronizes the data from the old service to the new service somehow. And then we're gonna need some kind of API logic, some place where we can run some code that will make some requests and run some code. We can put that API logic either in the client, or we can put it in the old service, or maybe we can put it in an intermediate service that we write, or maybe you can make your Envoy service mesh thing smart enough to do this. Like, I don't know. But I'm just gonna put it as a blue box floating in space there, but just know that it could go in either the client or the old service, or maybe if you're good at Envoy's WebAssembly or whatever, you could do that. So what does it do with this API logic? So the goal is it wants to make it so that the client doesn't know anything's happening, okay? Client keeps using the original API as if nothing has changed. This is the goal. So the way it does that is it sends the writes as the system is working, because remember, we can't take it down. So the system is always in use. So there are writes coming in, and it replicates the APIs that are doing these writes, and it sends them to both the old and the new. And not only that, it sends the reads to old and the new. But when it does that, it runs some of this logic I was talking about, which is to compare the answer. So at first, you're in a mode where you say, we're sending writes to both, and we're gonna send reads to both also, and then we're gonna compare the values, and then make sure that things are making sense. But that we're not actually gonna block anything if they don't. We're gonna, go out, make a metric out to, or log some event, or some way keep track of how well this thing is working. Okay. And what we send to the client is the reads from the old service. But we're still writing and reading. So we're running two things at the same time now. So our costs have now roughly doubled. Cost of doing business, unfortunately. So then, once we're confident that the metrics are showing that this is working well, then we flip that logic to say, now use the new value. But we need to keep using the old value, or keep the old value viable in case we notice some horrifying problem, which generally you do. Like often in the ones that I've worked on, we've gone back and forth. We flip it to use the new, and then we're like, oh no, there's some weird new subtle edge case. And we flip it back to the old, and we fix that, and we just keep flipping it back and forth until we get the answer that we're looking for. So finally, party time. You can turn that old thing off. You've crossed the Rubicon. There's no bringing it back. Migration complete. Good job. So I know what you're thinking. This sounds bad, and I told you it would. It is bad. And here are some reasons that you might specifically think, like, you can't possibly do this. Like, you can't do migrations this way. What if we use auto-incrementing keys? Well, you shouldn't do that. You shouldn't do that ever for any number of reasons. One is there will be a tendency to expose those auto-incrementing IDs in your externally facing APIs, which will allow people who would do you harm to either probe all of the boundaries of your authorization system by guessing IDs, because you've made guessable IDs now that this auto-incrementing thing is in the public API, but also competitors can now gain intelligence on your internal business metrics, such as, for example, people might just sign up and look at what their new customer ID is and just do that every day and then build a graph of how many customers you have. And they might place an order every day. They might place it multiple days. And they'll draw another graph and they'll completely understand all of your internal metrics just because you're using auto-incrementing IDs. Okay, so first bit of advice, never do this ever. Just UUIDs are great, random IDs, it's the way to go. If you do find yourself with auto-incrementing keys, you're probably gonna have to do some form of migration first to get off of auto-incrementing keys so that you can then get onto, some different system. Okay, what if one write fails and the other succeeds? So, in that picture, the API logic, it's just like making two RPCs, right? What happens? They don't always both work. And so this is, again, where it gets a little gross. You do at least have the advantage that you're only going to send the read back to the client. Like which one, which system you consider authoritative, right? Either the old or the new is authoritative at any one time. And so you could certainly at least send the client, the client response to the one, from the one that you're currently favoring, and just allow, and still tell the client that it worked. That's probably what you want to do. But remember how I said the very, very first step was you needed some kind of a backfill or synchronization. You probably have to run this regularly just to clean this mess up, unfortunately. So this is the big one. My API is super important and I need transactions. This is what everyone says. I need transactions. You're taking away my transactions. How is this ever going to work? Well, there are many different ways that people building very important systems that move money around or do otherwise important things have been able to be designed without requiring strict transactions. Earlier today, we've heard a couple different talks that discuss this. I'm not going to go into the details of how to avoid transactions, but it is possible. So see other green room talks earlier today for examples of how to do that. Okay, cool. So it sounds bad. It is bad, but we're going to do it anyway because we got to get rid of this. Got to get rid of this monolith. So okay, great. So here's how it works in our example. So remember, we want to add this order service, right? So we've got this new service, this new database, and we're going to run our background catch up sync process between the right tables in the Postgres and the right tables in the order database. And then we're going to get our API wrapper, which is really easy to do in something like Django. It's kind of cool because there's a very clear place where all the API calls go through. It's a single code base. So this is an example of putting the API in the old service as opposed to putting it in the client, which would, or in a separate service inline. And so imagine that an API request, comes in for something to do with an order. The API wrapper then does two things. It makes the normal Python function call that it would have always done, previously, and then it makes a gRPC into the order service. And so this is the dual write. And likewise, the reads work out the same way. It makes a Python function call to, read the order, and it makes a gRPC over to the order service to get the data back out. So the other way that you can do, so note that other blue box, the ORM, is actually another very nice place where all of the database traffic goes through. So just like all the API traffic goes through this API, front door, all of the database traffic goes through the ORM. And the reason you might want to do this is the reason that DoorDash did it, which is the Django API that we are using has some very nice features that are that let you get started very quickly and let client developers do things very flexibly, such as, for example, you can make a request that says, oh, by the way, I know I'm updating an order, But on the response value, I'm gonna need you to do a bunch of other stuff, like join it with these other, tables and pull back all this other different information that is all, it's like query parameters, so it'll be like update order, but then it will be like, question mark, also return arbitrary list of stuff, right? So this is actually what they were doing. And that made it very hard to do this at the purely API level because the API is doing all kinds of stuff. It's hard to know exactly, given a prefix of a URL, like what it actually is going to do. So what you can do is do the same dual write logic in the ORM, and then eventually you might need to do a sort of lightweight version of it at the API to switch it over, or maybe in this case, if everything is fully synchronized, maybe you can pull this off in the sort of internal, the ingress router layer. This is actually what we do for a number of these. So there is a surprising third option, and so it's kind of interesting because it maximizes the ugly, like it maximizes the gross factor in exchange for something. So in this particular case, what we've done is order service is sharing the database with Postgres. And that's kind of interesting. That's not usually what you see. And we taught the ORM how to do half of the dual write, but order service is sharing the database. And the reason for that is that new green box that's over there on the left, which is a new client using a new API. Okay, so the other clients are all using the old and boring API, and that's where we try to make it, remember the original goal was make the clients think that nothing has changed. And this one is just like, let's just get some new clients that work the way we want them to. And so it's interesting because it does allow you to make some progress, like some product progress, perhaps. Like this new client, lots of people will probably use it, and you're not necessarily stuck behind some multi-year migration before you can, ship new software or update your APIs. So what did we do? Well, we started with the database dual write because, like I said, we were using that external API had all that flexibility in it, and it was just like really hard to work with. So doing it at the API layer was too hard. Took a long time. This was before my time, but apparently I've done some archaeology on what the team had done, and apparently it just caused all sorts of problems. It corrupted a bunch of data, and it was really bad. Just everyone that was around then that's still here now, they all have kind of like scars, and they're like, if you're just, I don't even want to know how you're going to do it. I just don't even want to be involved because apparently it was bad. Anyway, after that really bad experience, they said, what we could just share the database for a little while, and then we can start, shipping new features, and we'll have that synchronizing process. If we make a really clever one, the really clever background syncing process, maybe we can use that as our kind of cutover switch when we're ready to go. Might violate the property of always being able to roll forward and backward, maybe a little, or not taking a maintenance window, I guess, is maybe the bigger one. But anyway, so they had their reasons, but the main one is that they didn't want to get stuck. They didn't want to get stuck, so it made everybody happier. So they're like, yay, we got a new client out there. It's got this new API. People like the new API. Developers like it because the old one was hard and the new one's good. And that was cool for a while, except supporting this thing with the shared database, and curiously the kind of currently the way that we're sharing the database to get this functionality out, it was hard, and it came at a time when we were growing a lot. We grew to the point where we could no longer use normal Postgres replication. So this was really unfortunate. So it's not really Postgres, it's AWS Aurora, like Postgres flavored Aurora. And during the pandemic, DoorDash grew a lot. We got to the point where we couldn't actually enable the write-ahead log. We had to use just magic Postgres replication. So the neat tricks we were going to pull to get our databases synced up with no downtime were increasingly hard to do because the thing got bigger over time. So we went back and we sort of went and applied a mix of both of these techniques, and we're slowly burning it down. Sadly, we had to do some force upgrades. So I don't have the exact number of engineers who worked on this, but I can tell you that when I was at Uber for our big monolith application, for at least a year, 25% of the engineering team was dedicated to retiring the monolith. Like 25%. And Uber had a much larger engineering team than DoorDash does, and so this is an incredibly expensive process. So, given the stakes, right? Like this is a lot of, if you get this wrong, where you're gonna dedicate a quarter of your engineers to like doing some migration, sounds bad. Well, so remember I said like there's probably one that's less bad. So the API dual write or the DB dual write, it's nice because it's always backward compatible, maintains that property. You've only got one external API to support, which probably makes your security people happy. It's like the fraud and the rate limiting and all that stuff. It's a lot easier to manage one external API. But it might be tricky if your external API is flexible or seems like a query language. That might make it hard. So also, if you've been around for a while, it might if your API's been around for a while, it might well be that it has begun to diverge from the actual data model that exists in the database. This certainly was the case for us in that made it harder also. But really the main thing to just get real honest with yourself about is you'll do this whole upgrade, and at the end of it, you will have two things that work exactly the same way that that your old one thing did. And strictly speaking, it might actually be like worse. Like you've not made any progress. You're on a new maybe tech stack, but like this whole time you sort of didn't make any progress. You just moved it. And that can be difficult to justify, especially from your business partners might have a hard time kind of coming to grips with that, right? So yeah, depending on which one of these you want to do, kind of depends on details of your thing. And so the shared database thing is interesting, especially if you have an API that sort of resists that kind of the clean migration of subsets of it. It might well be that you can do this and maybe make the business folks happy that you're still making some progress. Maybe it could well be, but what we found was, while at first everyone was happy, the ongoing operational complexity of having services sharing databases is really, really tricky. The longer it lives like that, the harder it gets. And like, for example, does everybody, are there caches, are there two caches, or are you sharing the cache, or you're sharing the cache, now you have code that in two different places that both reads and writes the cache and reads and writes the database? It's crazy. So, beware of that. And when you get all done with it, it might not be so clean to kind of flip the switch forward and backward. It might, if you have clever database people, maybe they can come up with a layer that you can use to sort of do this. But really for us, the big problem we had was everyone was excited that they got to work on the new thing. And then they were just like, I'm not touching that thing. The shared database, no thanks. That's got to be someone else's problem. And that's part of why this thing took too long. Anyway, I don't like this way. I think you should avoid it at all costs. But I wanted to bring it up not only because it's what we actually did for the majority of this migration, but also I think it is I think you can do it. It makes a very real business trade-off that if you're disciplined, I think it can work. But it didn't work very well for us, but who knows? So this all sounds bad, and there are some things though that you can do if you're building new systems that you can do to make it easier on future you or on whoever has your job after you get promoted or leave. There are ways that you can help. So the first one is maybe just never use an ORM. Like, they sound so tempting, but I don't think the productivity gains are significant, and the migration complexity is brutal. It's nice that there's one place that all the queries go through, but it's not nice that like if you want to change database technologies, you're gonna like kind of implement two different kinds of dual write, or I don't know. It's not a very good choice compared to explicitly managing queries that you just know exactly what the query is going to be, and you just write SQL or whatever you do, whatever your query language is for your database. Also, maybe just don't use Postgres. You just take the hit of people telling you you're doing it wrong, and just tell them you went to this talk or something, like, I don't know. But the single primary makes it very hard to always be up, to always be online. Upgrading it, I'm not even talking about migrations, I'm just like operating it. Like, how do you get the new version? Well, you just like take it down for 10 minutes and do the upgrade, and then you bring it back and you hope it worked. That same problem is there with migrations as well. Like the single one database that simply can't fail. It just makes it very, very hard to do these kind of migrations. So probably steer clear of that if you can afford the sort of going against conventional wisdom, I suppose. So event-based systems are very cool, and they fix a whole bunch of problems in exchange for some other ones. I'm not going to get into that. Other people have talked about that today. The thing that I would just point out with regard to migrations, if you have a mix of them, it's going to be much harder. Because we did. We mixed. The system was more than just RPC based. There were also like some Django things would send events to themselves, and then some microservice interfaces were event based and some of them were RPC based, and it's very, very complicated to do a migration around that for this reason, because it's not a very good abstraction if you do it that way. And I actually think the key, regardless of the specifics of like, an ORM SQL database, maybe that's just my opinion, or maybe that's just my limited experience. Maybe if I had done 1,000 migrations, maybe I would be able to speak more authoritatively about that. But what I think the real most important thing you can do is when you're building systems is use what I will call good abstractions. And I'm going to spend a little time getting into that. This is a definition that I have. I didn't get this from a book. This is just my own personal belief, but I like it. I think that this should be the goal, especially in your scaling out systems, you're building distributed systems, or you're growing teams. Like the same rule works for teams working in a monolith even, which is the abstraction should serve this purpose, I believe. And if it doesn't, I submit it as maybe not a good abstraction. It might be elegant or clean or adhere to some design pattern or something, but if you have to make changes on both sides of it every time or most of the time, I think that's probably not a good abstraction. So let's, the reasons for this is as you get more and more people working on this system, they need to be able to move independently. And if they're always having to coordinate with each other, that's hard. Like they need to be able to change something on one side of the abstraction rather than on both sides. Otherwise, adding more engineers doesn't actually make you go any faster. Also, I hear this a lot. People say, oh, if we just use this framework, we will get all of this stuff for free. If you ever hear that, my advice is don't believe it because it is almost never true given time. Given some amount of time, that freeness, someone's going to have to pay for it. This might be actually my favorite version of the technical debt metaphor, which is like anytime somebody says something you're going to get for free, it means someone is going to have to pay it back later. So here's a fun thing to do. Think about abstractions that you have in the system that you work on and try to apply that definition to it. Like, can you make a change to one side of it, a meaningful change, like something that helps somehow? Can you make a change to one side of the abstraction without coordinating with the other side or making a change on the other side? Or like, how much of your work can you do like that? So here's a couple specific examples. Like, is GraphQL a good abstraction? I mean, certainly from the client's developer's perspective, it is. It's great. You can make all kinds of changes, change stuff all day long. It's cool. It's query language. Good job. Unless you do it really, really strictly and carefully, I would say this generally doesn't hold true on the back end. Now, can you throw lots of engineers at it like at Facebook or some other big company? Yeah, sure, of course you can. But is it a good abstraction? I mean, not by default. I would say probably not. This one's sort of a trick question, but is Kafka a good abstraction? And I think the answer is, it is a trick question because it's too low level. By itself, it's not. You need to layer something on top of it. Like there's some framework, some message format, some way of getting data into and out of Kafka. That's the abstraction, and you should still be able to apply that property to it. It might actually make it easier to apply that property to it, but it won't by default. Like you don't actually get a good abstraction for free. Like you gotta work at it a little bit. So wrapping up a little bit, why are all these migrations so hard? Like it's all ugly and it's all just doesn't seem good. The main reason is because everybody builds custom solutions. When they have these problems, they build their own custom internal tooling. This talk that I just gave today, I could have given it 5 years ago or 10 years ago. Maybe I would change GraphQL because not a lot of people knew about it 10 years ago, but or did it exist? I don't know, doesn't matter. The point is this migration problem hasn't changed in 10 years. So like here we are, we were doing dual writes 10 years ago and we're still doing them now. Everybody builds their own thing and it just vanishes in their internal code. And it's hard to justify with your business partners, like the time it will take maybe to sort of build good abstractions versus product features. And I think good abstractions is definitely the way to think about it, but yeah, I understand, it's hard. Another big problem that I notice is a lot of people, they take this premature optimization is the root of all evil, saying, and they apply it so hard that you can never optimize anything. They're just like, optimization, who cares? I don't want to do it prematurely, so let's just never do it or ever even be able to do it. Is unfortunately what I somehow people have kind of interpreted that. But like, look, why is it really so hard? It's because these things they're not adding direct business value, and they're going to be hard, and you might break something, and after a while you just go, this is just, maybe we can just deal with maybe we can just ignore it for another year, or maybe like I don't know, and just after a while you just start thinking, this is too hard to do. Let's just not do it. And another related problem is, for whatever reason, senior engineers don't think this is interesting, which is really curious to me. Like, it's so hard. Engineers want to work on hard problems, so they say. Why don't they do every migration ever? Like they should. They should build this tooling, right? And importantly, though, you get what you reward. And I think if we rewarded engineers for working on migrations, I bet you'd find that we suddenly got some good tooling and, like this got easier for everybody, right? Because it is good for your career. But, until we fix that problem, it's probably not going to change, and I'll probably have to give this talk 10 years from now. But as senior engineers, that should be your job. That should be your job is leverage. And these kind of migrations have tremendous leverage because they're so expensive. So if you can find good ways to automate doing these migrations, building these frameworks, building the comparisons, all that dual write stuff, whatever. This is tremendously leveraged work, and I wish more people would do it. Anyway, that is all I have. Thank you very much.
Thank you, Matt. That was a very interesting talk. We've got a few minutes left, so let's try with three questions maybe. Hands up. Oh, got to walk all the way there.
Hi. Can you share your experience regarding software engineers' opinions when you are doing such migrations? Because you need to take their suggestions and their way of doing of work and their opinions, right? So there will be maybe 10 engineers. And how did you deal with that?
Yeah. I mean, look, I'm compressing this into what we can fit into 45 minutes of me talking at you up on this stage. But what I'm hoping you can do is guide engineers past whatever their current wrong opinions are, to get them to build better systems that are automated and safe to move forward and backward and make migrations easier. Everyone thinks they're hard, and we can spend all day trying to understand why they think they're hard. But I think the real issue is to motivate people, or the real thing to do from a management perspective is motivate people that this is an automatable problem. That is my very strong recommendation. This is a hard engineering problem. You will get rewarded. You can write software to fix it. It's what you want. Automate it.
Next question. Yep.
You mentioned that you recommend not mixing RPC and event in the same architecture.
So certainly in the same data model.
Okay.
Yeah.
So why is can you go a bit deeper on that?
Yeah, sure.
How do you fix that in an organization?
Sure. So the reason that I should have maybe said a couple more sentences about that. So the reason that makes it hard is because in a purely RPC model, you've got the one, that API logic blue box where you're making the decision of are we using the old one or the new one, which one are comparing and which one are we returning. Now you have to have that in two places. Because now you need some way of also doing that for every event you produce and consume. And it's easy if you have one or it's easier if you have one or the other. But as soon as you have two ways, now you have to implement the same kind of dual write logic or something, whatever the equivalent of it is on the event side. And it might actually be easier to do this in some cases for event-based systems. The point is it's different. And so now you have two places where that logic has to live. And it's just much harder to sort of understand how much progress you're making is certainly what we found. It was very easy to say, hey, look, traffic through the API server, it's going down, we're getting this. But all the events are flying all over the place constantly. We'll end up with the same number of events when we're done. It just makes it easier to sort of reason about and operate whatever tooling you come up with, but not impossible.
Okay, one last question.
Hi, I have got a question here. So currently I'm doing a sort of migration on the AWS, and it's an Aurora Postgres database. I'm wondering, my question is, how do you comment the AWS tool like DMS, the database migration tool service, to do this migration? So, for example, it will sync data. The original database and the ongoing changes over.
Right. That could be a useful component to your system. Absolutely. I think it's especially useful for that. the thing that I kind of brushed past really quickly, which is you need some way to keep these databases in sync while you're doing that work. I think if it works for you, the DMS could be great for that, absolutely. But like you probably still need the gradual forward and backward with comparison logic, like to make sure that everything is working correctly. Because just because you migrated all the data, it might actually not be right, and you might flip the switch to use it, and it blows up, right? So that's why that blue box in the middle that's reading and writing to both systems at the same time is so important, because you know it's going to work, because you're already using it, right? Like there is no time where you suddenly find yourself using it, and then you hope you didn't break anything. You've been using it constantly, the whole time. So. You get metrics that says it's doing the correct thing. So when you flip that switch, it's very, very safe to do so. And I haven't seen any tooling from Amazon that fixes that problem. Like maybe they sync the data for you. Unfortunately, we couldn't use it for the same reason that we couldn't do our own clever trick, which was our Aurora was too busy. And once your Aurora gets too busy, you can't use the nice stuff.
All right, thanks, Matt. How about a big round of hands for Matt?